Hi, this is Khaled from Navitas. We're sharing this video with you today to illustrate some of the capabilities that we have in Navitas engineering, which is mainly related to the wind tunnel testing. The wind tunnel testing usually is done as a physical test where a physical model is built for a specific area, and then this is put in a special lab where wind is generated, and then the specific building that needs to be studied, for instance this one, will be filled on the physical model with a lot of sensors all around the facade to make sure that the loads generated from the wind are recorded, and then these values are given to the structural engineers, facade consultants, to be able to carefully design the facades or the cladding systems, whether it is stone, metal, according to the generated or resulted loads. Today, with the enhancement and the advancement that we have seen in the softwares, this is possible to be done digitally. So actually in this case we have built the full model for one specific area. This is in Amman, Jordan, called Al Abtal area. So the buildings has been done in 3D with different heights. The highest one here, which is Rotana, is around 180, and we have other buildings 120, we have 28, 25 meters. So the whole model is generated, and then we have to identify the direction of the wind. We can build several scenarios, several case studies, and define either the velocity of that wind or the pressure, design pressure, which might be, for instance, 1.4. Also, we can also generate or build a special profile for the wind, and identifying that the wind at, let's say, the first 50 meters height is 1.4, then it's increased to 2.4 till the height of 100, then above that it is, let's assume 3 kilopascal. Eventually the simulation is going to take a lot of time, so we have already generated a couple of cases that we want to show you. So for instance, our first case, we have a wind coming from the west with a wind velocity of 35 meters per second, and I'm going to share with you the results. So as you see in this illustration, the resulted forces on this, let's say, specific building as demonstrated by color, so reaching from minus 0.75 kilopascal up to a positive of 0.75 kilopascal. So you can see here we have a positive wind pressure on these areas, while on the back of the same building we have a negative, but the highest negative is on the sides. So this has to be studied. The illustration is done, of course, on the full model, not like the physical on a specific building, and you can easily now generate, or we can provide the full details for each of these specific surfaces, whether it is horizontal, whether it is vertical, tilted. It doesn't really matter. We give you the full information about it. Let's review another case study where we have assumed a variable of wind load starting from 1 kilopascal at the bottom, reaching up to 2.4 at the top. So same case, you can see now the different results depending on the different case studies. Automatically the program generates the loads on each of these surfaces, where we can actually take it to other softwares and do more analysis. Within the same software, we can detail a specific building to have parts where we have aluminium curtain wall, other parts where we have cladding, and carefully study each of these elements separately and generate a full spectrum of wind loads that needs to be accounted for during the engineering of any facade for these buildings. We hope this information is beneficial. Please contact us if you need further information, and thank you very much for your time, and have a nice day.